All right, this is the first lecture that we're going to do. This is pages 1 through 12 in the notes packet that I posted. So if I were you, I would print it off and follow along with me. Generally, I would be writing on an iPad and you'd be able to see what I'm writing. However, my pen and iPad are not currently working, so I have typed the notes on here today. So hopefully you can follow along with me and fill in your notes and answer any questions that I have for you on the video. So let's get started. Okay, so overview of chemistry in general. We are obviously going to learn a lot this semester, but what is chemistry? It is the study of matter and the changes they undergo. So when I'm talking about chemical reactions, that's how matter changes, why it changes, how we can make it change, those types of things. There's all kinds of applications and examples, of course, which I'm sure that you know. You might have been able to come up with the fact that chemistry is engaged in many other sciences, including geology, environmental science, which is a very large field to go into right now, physics. If you're looking into healthcare, chemistry is absolutely related in there. What does the molecule look like? What is it going to do? Biochemistry, of course, how the body works and the chemicals involved in that. Any type of food science or industrial science when you're trying to create things. And there's a whole bunch of other different applications as well, but this is kind of why we care about chemistry. It can be incorporated into many other different studies. So just one example of an application of chemistry that this was actually found in the 70s, answered the question, what happened to the dinosaurs? So, right, we say it was a meteorite, but how did we figure that out, right? There's actually this layer, and if you're looking at this mountain that I have in the picture, there's a KT boundary, so this really defined line, and this is actually off the coast of Mexico. It's in the Gulf of Mexico, right here. There's this big crater, okay? So this KT layer is actually the layer of sediment that was deposited between the Cretaceous and the Tertiary period, so right when the dinosaurs became extinct. There was unusually large quantities of iridium, and you might have heard of iridium before, you might not have. It's an element on the periodic table. The periodic table is what we use in chemistry. Iridium is actually very rare. It only comprises this very, very small percentage of Earth's crust. And when we find it, it is generally only because of meteorites that have struck the planet. So we can kind of put two and two together. There was this higher concentration of iridium, which must have meant that there was a crater right here. So they could figure out how big it was. They could figure out how big the impact was, how fast it was going based on the size of that crater. And that's how we were actually able to determine that this crater is most likely the cause of what made the dinosaurs extinct. So just one example of the many applications that chemistry and the periodic table can have.